Welcome to the Explainer. Today, we're going to lay out a clear roadmap to help you navigate the pretty complex world of backend engineering. This is all about seeing that big picture and really understanding how all the different pieces of the puzzle fit together.
If you're just starting out, it can feel like you're totally drowning in resources, right? There are thousands of courses, endless tutorials, and it's just so hard to know where to even begin. It makes seeing a clear path forward feel almost impossible. So, let's kick things off by looking at a few common pitfalls. You know, a lot of learners get stuck in these same traps. One of the biggest ones is jumping straight into a specific framework, like Express or Spring Boot. Now, don't get me wrong, they're great for building stuff fast, but they create huge blind spots. You learn how to use the tool, but you totally miss the fundamental principles of what's actually happening underneath. And that leads to skills that don't really transfer well, and it can take years of just messing around to finally connect the dots. So, how do we fix this? Well, the most effective way to build a solid, transferable foundation is to simply trace the journey of a single user request. We're going to follow it from the exact moment it leaves the browser, travels to the server, gets processed, and then all the way back with a response. This approach just naturally reveals the core concepts that apply to any language or framework. All right, so our journey kicks off the second a user interacts with an app. Let's say they click a button. That one little click fires off a request that has to be sent to a server, which could be thousands of miles away. At the heart of this communication is the Hypertext Transfer Protocol, or as we all know it, HTTP. The best way to think of it is as the universal language of the web. It's a set of rules that make sure the client and the server are speaking the same language and can understand each other perfectly. So what makes up this language? Well, this slide shows the core grammar. You've got methods, which are basically the verbs of the request, like get to ask for data, post to send new data, or delete to get rid of it. Then you have headers, which give all the important context and metadata. When the server replies, it uses status codes to tell you what happened, like 200 OK for success, or the infamous 404 not found. This whole system also includes rules for caching to speed things up, and security, using SSL/TLS to create that secure HTTPS connection we all look for. It's really a complete package for communication. So, the request hits our server. Now what? It needs to go to the right department, right? That's where routing comes in. It acts like a GPS for our application. It looks at the URL and the method, and it directs the request to the exact piece of code that knows how to handle it. Okay, the request has been routed. Now it's entering the core of our application. You can think of this part as the server's brain, where all the real work gets done. And inside that brain, you have middleware. Honestly, the best way to picture this is like an assembly line. Each middleware function is a stop on the line that does one specific job. Maybe it logs the request, or checks if the user is logged in, or validates the data. The request just passes through this chain, one stop at a time, before it gets to its final destination. Now, before any data can actually travel over the network, it has to be packaged up, or translated, into a standard format. That's called serialization. And this slide shows a really key trade-off you have to make. Text-based formats like JSON are easy for us humans to read and debug. But on the flip side, binary formats like protobuf are optimized for machines. They're way smaller, faster, and more performant. But they look like gibberish to us. This next step is all about security, and it is absolutely critical. First up, you have authentication. Think of this as the bouncer at a club checking your ID. It's all about verifying who you are. Then you have authorization. This is the bouncer checking the VIP list to see if you're actually allowed to go into the special section you're asking for. Two different, but equally important jobs. This is where the real magic of your application lives. The business logic layer holds all the unique rules and processes that make your product special. And what's really important is that this logic is kept totally separate from how the data is shown to the user or how it's stored in a database. That separation makes the whole system so much easier to manage and update. Sooner or later, that request is probably going to need to talk to a database, which is really the application's long-term memory. And as you can see here, you've got two main flavors. You have relational SQL databases with their super structured tables and strict rules, and then you have non-relational NoSQL databases, which are much more flexible. SQL is fantastic for complex queries on data that's all interconnected, while NoSQL is usually built for massive scale and less structured data. But, not all work can happen in the split second it takes to respond to a request. Some tasks are just too big or too slow. So let's take a look at how backend systems handle all the complex, long-running, and heavy jobs. For those jobs that take way too long, like sending thousands of emails or processing a huge video file, we offload them to something called a task queue. This is a game changer because it means the server can immediately tell the user, "Yep, got your request," without making them sit there and stare at a loading spinner. And this is absolutely essential for a good user experience. Think about it. Sending a ton of emails, processing big images, running massive reports. By moving these tasks to a queue, the application feels fast and snappy to the user, even while all this heavy computation is happening behind the scenes. Another great trick for speeding things up is caching. It's a brilliant idea, really. Instead of making that slow trip all the way to the database every single time for the same piece of information, we keep a copy of it in a super fast temporary spot. It's like a librarian keeping the most popular books right at the front desk instead of making you go to the archives every time. Look, having an app that works is one thing, but in the real world, that's not nearly enough. Your systems need to handle thousands, maybe millions of users, stay online 24/7, and be totally secure. This is what really separates a hobby project from professional-grade engineering.
This brings us to observability, and it's so much more than just knowing if your system is down. It's about having the tools to understand why it's behaving in a certain way. It lets you ask really complex questions about your system, and actually that answers, even for problems you never saw coming. And these are the three pillars that make that possible. You've got logs, which are just records of specific events, like user X logged in at this time. Then you have metrics, which are numbers over time, like CPU usage that show you high-level trends. And finally, you have traces, which follow a single request as it hops through all the different services it needs to. Together, these three give you an incredibly complete picture of your system's health. And of course, security. This can't be an afterthought. It has to be foundational. This means building in core principles from day one. For example, the principle of least privilege means you only give a piece of your code the exact permissions it needs to do its job and absolutely nothing more. Defense in depth means you have multiple security layers. Input validation is simple. Never, ever, ever trust user input. And rate limiting protects you from abuse by stopping a single user from overwhelming your service. So here's the real bottom line. By following the request's journey, you're not just learning one framework or one language. You're learning these timeless, fundamental principles. Routing, serialization, caching. These are the concepts that will serve you for your entire career, no matter what new hot technology comes along. And that's our roadmap. By just following the path of a single request, we've basically drawn a map of the entire backend world. We found the path through the maze. Now the journey is all yours to begin. Thanks for tuning into The Explainer.